Let's talk about second type of questions based on Venn diagrams. These are typically known as maxima minima or non-deterministic type questions because unlike deterministic type questions which we saw in the last video, these questions don't provide us with the complete data. There are several parameters which are unknown, and based on the given information and of course logic, we are required to find the minimum and maximum value that any parameter can assume. Let's start with an example. Two different brands of shoes are surveyed. 65% preferred Puma and 95% preferred T-Bog. Then maximum and minimum number of people who preferred both the brands is asked. The first thing that we do here is make two intersecting circles, one for Puma and one for T-Bog, inside a rectangle which represents the universal set. Puma is preferred by 65% people, T-Bog by 95%. Universal set has to be 100 as we are dealing in percentages. Let's denote the intersection by Z and the percentage of people who didn't prefer any of the brands by N. Now, if we talk about union of Puma and T-Bog, it has to be Puma plus T-Bog minus their intersection. So, 65 plus 95 minus Z, that is 160 minus Z is the union. Here we can't tell the exact value of union or Z or say N, as their values will depend on each other. That is the reason why these questions always ask for range or maxima minima. Now we have union is equal to 160 minus Z, or say union plus Z is equal to 160. Let's try to figure the minimum value of Z using the trial and error method. Can Z be equal to 0? Or in other words, is the case of these sets being disjoint sets possible? In that case, union should be equal to 160, but it is not possible, as we know that maximum value of union can be 100 only, as universal set is 100. If we put this maximum value of union, that is 100, in this equation, then we should get the minimum value of Z. Is this clear? Union plus Z is 160. Sum of two variables is constant. So, for one to be minimum, other has to be maximum. If union is 100, then Z minimum in that case would be 60. So, minimum value of Z, or say minimum number of people who preferred both the brands, is 60%. If this Z is 60, people who prefer only Puma becomes 5% and only T-Bog becomes 35%. Union is 100 and hence N, that is percentage of people preferring no brands, becomes 0. So, a very important point, if we want to minimize those who like both, that is intersection part, then we have to maximize the value of union. And in this process, value of N, that is people preferring none of the two, automatically becomes minimum. Now, we have to find the maximum percent of people preferring both the brands. We have minimum value of Z as 60. Can we put Z as 65? If I put Z as 65, then people preferring only Puma becomes 0. Only T-Bog becomes 95 minus 65, that is 30. And people preferring none becomes 5% in this case. If I put Z as 70, then it contradicts with the given condition of people preferring Puma as 65%. It will be more than that. So, 65 has to be the maximum value which Z can assume. Another important point, if we want to maximize those who like both, that is intersection part, then we have to minimize the value of the union. And in this process, value of N also becomes maximum. Always remember that this maximum value is limited by the lower of the two values that both the sets have. Let's solve a 3-set based maxima minima problem. Pause the video and try to attempt it on your own. The question talks about a class of 92 students opting one among three subjects: physics, chemistry and biology. It is also mentioned that they have a choice of not choosing any of the three subjects. This line is important. First, represent the given data in the form of Venn diagram like this. We know that union of three sets is equal to P plus C plus B minus P intersection C minus C intersection B minus B intersection P plus P intersection C intersection B. Now, this is very important. In the previous example, that is in cases involving two sets, we used to subtract the intersection of the two sets. So, whenever we required minimum value of intersection, we maximize the union. But here, in union of three sets, part common to all three sets is getting added. So an important point to keep in mind, whenever we want to maximize all three, or say we need to maximize the intersection of all three, we do it by maximizing the union of the whole set. Now, union is equal to 60 plus 80 plus 50 minus 40 minus 45 minus 50 plus the intersection of all three, that is x. Simplifying this, we get union is equal to 55 plus x. As union and x are directly proportional to each other, so if we increase LHS, RHS will also increase. So union maximum will give us x maximum. Union maximum can be equal to universal set, which is 92. So x maximum is 92 minus 55, that is 37. This part is not over yet. Always remember to cross-check the answer that we have got. In this case, 37 is less than all the values which are given. So, we can safely assume it to be the final answer. But suppose, instead of 92, total number of students, that is, universal set was given as 100. Then, union maximum would have been 100 in that case. And x maximum would have been 100 minus 55, which is 45. Now here, if you observe the intersection of physics and biology, it is 40. That means x cannot be greater than 40. So the answer in that case would have been 40 and not 45. So always, I will repeat, always verify the answers that you get. The limiting condition will be the smallest value among the three sets. Now, to calculate the minimum value of this intersection, consider each set separately and look at the subsets that each set contains. For example, consider the main set chemistry, which contains two subsets as physics intersection chemistry and chemistry intersection biology. So this diagram can be transformed to this diagram. We have considered chemistry set only, so it becomes universal set now. Physics intersection chemistry and biology intersection chemistry are the two sets inside it whose intersection is x. Now here union will be equal to 50 plus 45 minus x. Maximum union can be equal to the universal set C, that is 80. When union is maximum, x is minimum. Here we are dealing with two set cases. So x minimum has to be 50 plus 45 minus 80, which comes out as 15. Wait, this is not the answer yet. It is specifically for chemistry set only. The same thing has to be done for the other two sets as well. Next, take the physics set which contains physics intersection chemistry and physics intersection biology. Here, union will be 50 plus 40 minus x. We have union maximum as 60. So, x minimum will be 50 plus 40 minus 60, which gives us x minimum as 30. It is specifically from physics set only. Last set, biology. It contains physics intersection biology and chemistry intersection biology. Union will be 40 plus 45 minus x. Union max is 50. So, x minimum will be 40 plus 45 minus 50, which gives us 35 as the minimum value of x from biology set. The minimum value of x equal to 35 will satisfy the other two conditions as well. Overall, x minimum has to be 35. If you try to put x equal to 15, 30 and 35 in the set biology, you will figure out that only x equal to 35 will satisfy the given condition. X minimum will come out to be maximum of 3 obtained values. I hope this video was helpful in bringing some clarity regarding the basics of maxima and minima based on Venn diagrams. Thank you for watching.